Good afternoon, everyone. Dear authors and invited guests, welcome to the technical session 11B. Myself, Aarti Mohan, and the session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it's my great pleasure to welcome you all to the Third World Conference on Information Systems for Business Management ISBM 2024, Bangkok, Thailand. The third edition of this conference is being organized in hybrid mode. The virtual event is being held through Zoom today, that is 13 September 2024. I hope you all would be enjoying this knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter would be given 12 minutes for the presentation and 3 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants to stay connected with us till the closing remarks. If you have any sort of queries or any updates, you can write it to me in the chat box. Just before we get started with our session, I would like to introduce you all to the session chair, Dr. Deepak. We welcome you, sir. Dr. Deepak is currently working as an associate professor, Vishwakarma Institute of Technology, Pune, India. He has 17 years of teaching experience. He has written books on machine learning, fundamental of programming languages and principles of programming languages for computer IT students. His main research work focuses on machine learning, deep learning, and supervised clustering. It's an honor to have you here on board with us, sir. We welcome you.
Thank you, ma'am.
Moving on, thank you, sir. Moving on to our first presentation, I would invite the first presenter to present his paper on a quantum machine learning model for supervised classification. Dear presenter, could you please proceed with your presentation?
Yeah. I'm sharing the presentation. I hope the presentation has been shared. Hello?
Yes, sir. It's visible to us.
Yes.
You may please proceed.
Yeah, good afternoon to everyone, and especially the chief guest, Dr. Deepak. I would like to mention about my paper title. It is about quantum machine learning is for supervised classification. I'll just quickly go through the presentation division, like the abstract, introduction, and QML, and of course, how we implemented and results and conclusion. Basically, the paper explores about quantum machine learning model for classification techniques. So we try to investigate on binary classifier this time using quantum binary classifier using 2 qubits. Quantum computing uses qubits as a basic structure for that one. We will come across this thing in the next slide. And of course, for doing the simulation of the quantum, as you are very well know that we don't have a quantum machine computer, but we have a hybrid schemes where we can use a simulator. One of the simulators are Penny Lane. We can use that API to simulate qubits and so on and so forth. So we use a Penny Lane amplitude encoding. And also we considered using a synthetic dataset, which is a basic dataset. But we try to achieve the accuracy to the maximum level by using only 2 qubits. So going forward, this is the basic quantum computing structure. Of course, quantum computing is used for solving complex to fundamental problems using photons, and that is basically called as a qubit, where we call as zeros and ones bits. It is called here a qubit. That is the building block of quantum computer. Normally, these qubits are generally notation as brackets, BRAKETs, or they are called as Dirac notation. The ones which is in the 0 state is called is 1 0, and the one which is 1 state is called 0 and 1. So, and the quantum circuit is basically a comprising of N not and like the traditional NOT gate, AND gate, NOR gates. But whereas here we represent them as RY, RZ gates. If you see in the PPT, the image which is been showing here is a basic quantum circuit, one part of a quantum circuit with some gates also. You can observe there are zero states at the end, and then the circuit which is showing as a meter is the one which is representing an output. In between, we do a lot of operations and by using gates. One of that is called Hadamard gate, and then we'll go through this explanation in the next slides also. This entire figure is called as a quantum circuit. So there are, when you are writing a program, you create a quantum circuit declaring a qubits, and then you do the operations, the operations which we are doing traditionally using a Jupyter notebook or any Python coding language. So, and machine learning is, everyone is aware of machine learning, but when you combine machine learning with quantum computing, it is called quantum machine learning. So if you see this diagrammatic representation, you use Python and machine learning techniques and optimization and basic math also, along with quantum computing, which actually stands on the top of it. And when we mix all together, we can achieve a quantum machine learning. The basic aim of this paper is to make the people know that how a quantum computing can be extended for machine learning techniques. It's a basic step what we try to do. When we ventured into it and try to get a result, that is the main aim of this paper. The methodology is like, as I mentioned earlier, the quantum computing program runs on a device. That's a basically, let us talk it as a circuit, because we are using a basic circuit, and these things we can be run on directly on a quantum computer. But as we have a very limited or no access for quantum computer, we can run it on a simulator. So the one simulator which we choose is a penny line, which is very famous, which is available on the internet. It is free to choose, free to use also. And we declared the basic quantum qubits and other q nodes, everything using the penny lane. As such, we are running running the things on the quantum computer. But the main problem here comes is that we run it on a traditional Jupyter notebook only. We no need to run on any quantum computer and all, or we can run on a laptop also or desktop. This is what we did it here. So what we did is that in this quantum machine learning code, we tested and trained the code using the cost function, which is called q node conversion cost function, and then the specific number of steps were used for optimized result. And when you are selecting optimized steps, you have to use a cost function for that one. So I think the next slide will explain that in depth. I don't know if you are able to see a clear code here. So if you use import penny line as a QML from, and then the templates have been embedded into that one. If you observe at the third line, you can see the circuit definition here by using Hadamard, and then we use the angle embedding for optimization also, and then subsequently for the circuit declaration also. And then once the circuit has been declared, use a variation classifier to do your general machine learning operations, what we are traditionally doing. So this study mainly aims to determine how many qubits will actually needed for us to get a proper accuracy of the classification. The first step itself declares the qubits. We use a n dimension, but whereas we can directly put it as 2. That's what we did it in this code. So when we reduce the dimension to 2, or as required when we are talking about the mention the abstract, the accuracy is pretty much on the level of 83. And every time when you're running the iterations, we are going on the upside also. Sometimes we are getting on the downside, but probably this is a implementation of initial implementation of a binary classification technique using quantum machine learning using penny lane. And of course, we used an optimizer where to regulate the minimum loss. You can see the Adam optimizer here. And the final conclusion is that the machine learning algorithm based on quantum computing, thus promoting the development of quantum computing and quantum technology. So only promoting about those things. And then this may give a better idea for people to implement machine learning and quantum computing using a simulators. Sorry. In conclusion, the paper highlights training algorithm for binary classification using quantum circuit. The cost function is explicitly based on quantum correlation. The approach was done only with qubits. That is what we are mostly stressing here. But more can be considered. But we observed when you are increasing the qubit, the accuracy is coming down. Probably we need to tweak some more lines of codes in the implementation of variation classifier that we have to explore it. And then further, this model can be extended for other traditional machine learning programs with very complex data sets. This is the presentation from my side. Thank you.
Okay, sir. Can you tell me the more about how quantum algorithm is mixed with the machine learning algorithms and how it is better than existing machine learning algorithms? So can you tell me the one case study where you can say with combination of these both, you are improving the performance on some for particular task?
Yes, sir. Thank you for the question. And then first thing is that the current paper itself is a best example for binary classification, sir, which has a traditional accuracies are maybe less than 95 and all. We have not tested definitely with complex data sets, but when you go with a normal data set with two qubits only, we are achieving a very good accuracy, more than 95. That is the first example, sir. Second thing is that the second question what you asked about implementing quantum machine learning on the quantum computer, we use a API called as Penny Lane, which is a freely available in the internet and it is downloadable. The API is very open to use. They have good material also available, and it integrates easily with the existing machine learning algorithm techniques. Only thing we need to do is that the one which I showed the slide, where we need to create a quantum circuit is the main concept here. And then declaring about the qubits, where that is the only part where we need to do the tweaking. The rest is all same as what we do in the traditional machine learning algorithms.
Okay, and when we are saying the quantum algorithms, can you tell me the some contribution? What is the new thing in this proposed model?
Yeah, actually, Penny Lane API is the very new one, sir. It's a new introduction. Very few literature is available in the internet also. They are a third-party open source GitHub things, and we try to implement it. As such, there is not much literature available on the net also, and very few people are venturing into this area because understanding Q node, qubit, and circuit itself is a different task, and implementing we require a quantum computer, whereas we simulated that one using a third-party API that is called Penny Lane.
Okay, thank you, sir.
Thank you, sir. Thank you.
Thank you.
Thank you, sir. Thank you so much for your presentation. Thank you, sir, for your questions.
Thank you, madam.
Moving on to our next presentation, we have our presenter to present her paper on consumer susceptibility, the role of social comparison, reference group, and values. Dear presenter, could you please proceed with your presentation? I repeat, the paper title is Consumer Susceptibility, the Role of Social Comparison, Reference Group, and Values. Moving on to our next presentation, we have development of a smart real-time electronic price tag management system using Bluetooth and cloud database technologies. Dear presenter, could you please proceed with your presentation?
Good morning. everyone. Okay. Sure.
Dear presenter, may I know your name,
Sorry, can
please?
I see my screen now?
Yeah, your screen is visible. May I know your name, please?
Oh, my name is Adetumila Raditayo.
Okay, thank you. Yeah, you may please proceed with your presentation.
Okay. Good morning. My name is Adetumila Raditayo, and I'm here to present my project titled Development of a Smart Real-Time Price Tag Management System using Bluetooth and Cloud Database Technologies. And this presentation was supervised by Dr. Kennedy. So here's the outline of today's presentation. I will cover the following sections: introduction, problem statement, aims and objective, methodology, implementation and results, and finally recommendations and conclusion. In the Nigerian real-time markets and similar markets worldwide, the exchange rate between the naira and the international currencies like the dollar fluctuates frequently. These changes directly impact import costs and, as a result, retail prices. Prices can change not only just daily but even hourly, making it challenging to keep price tags. Sorry, making it making it challenging to keep price tags updated manually. This project seeks to address the issue by developing a real-time price tag management system that leverages Bluetooth technology and a cloud database. The key problem here is the change exchange rate, which causes unpredictable price fluctuations. Supermarkets struggle to maintain accurate price tag both on shelves and in their databases. The manual process is very labor intensive and also prone to errors, leading to discrepancies between the displayed prices and those at checkout, which frustrate customers and create inefficiencies. The aim of this project is to develop a smart real-time price tag management system using Bluetooth technology and cloud database. To achieve this, I focus on five main objectives, which are to develop price tag using the Bluetooth module, integrate pre-programmed Africa platform into the point of sale and central management system, use cloud technology for communication between the central system and the point of sale, implement Bluetooth technology to update prices on electronic price tag, and then test the accuracy and efficiency by automating price and updates. So this is the conceptual framework where this is the central management system, and it manages the pricing data and ensures that the updated prices is synchronized between the database and the electronic price tag. So once you update the price, it sends it to the electronic price tag via Bluetooth, and it sends it to the point of sale system via the cloud database, which stores the price data and then synchronizes it with the point of sale system. This is the circuit diagram I used for the price tag, and then the system is powered by the USB connector, providing electricity to the display as well as the Bluetooth module. And the central management system sends the updated price information via Bluetooth, and then the Bluetooth module receives the data and filters the data based on the unique ID of each price tag. If the data matches the price tag unique ID, the price information is then transmitted to the display over the I2C bus, which is inter-integrated communication. So the display shows the updated price on the screen, providing real-time visibility of the product price to the customers. The system was implemented and tested in several key areas, which is price accuracy and response time. Price accuracy, the system ensured that the prices displayed on the electronic tags matched the updates made in the central management system and the point of sale system. Then the response time, real time updates were achieved with response time of few seconds from when the prices were updated in the system to when they appeared
Hello, dear presenter, are you there? Am I audible? Hello, am I audible?
You are audible. You are audible. Vash.
Yeah, thank you, sir. Dear presenter, are you there?
Hello?
Yes.
Okay, can I continue from where I stopped?
Sorry.
Can I continue from where I don't know. I got disconnected. Can I continue from where I stopped?
Yeah, you may please continue.
Okay. So I think I was in implementation and testing. So um the system was implemented and tested in several areas: price accuracy and response time. The system in price accuracy, the system ensured that the prices displayed on the electronic tags match the updates made in the central management system and the point of sale system. And then in response time, the real-time updates were achieved with response time of few seconds from when prices were updated in the system to when they appeared on the price tags. So recommendation to further enhance the system, I have a recommendation: by incorporating machine learning algorithms, the system can analyze sales strength and customer behavior to automatically optimize pricing strategy. And then in conclusion, this project has developed an efficient and real-time solution for managing retail prices using Bluetooth and cloud database technologies. And the system automates the process of updating prices on electronic price tag, ensuring accuracy and reducing manual errors. By integrating this technology, we have improved customers' experience and streamlined operations in retail environment. Thank you very much.
Thank you. Thank you so much for your presentation. Sir, you have any questions?
Okay, can you compare your result with existing approaches, because you have not said anything about that?
Sorry, can you repeat yourself again?
Yeah. So whatever you are presenting, ma'am, can you compare your result with the existing?
Oh, okay. Some of the various some of the various electronic shelf labels, they used LoRaWAN system, and LoRaWAN is not real time. We focus on real time. That's why we use Bluetooth.
Okay, and what about novelty? What is your contribution?
My contribution is adding Bluetooth to make it more real time. Bluetooth technology in order to make it real time, so that when you update it, it will not like take, it will update immediately. It doesn't take time.
Okay. Okay, thank you.
Thank you very much.
Thank you. Thank you so much for your presentation. Thank you, sir. Moving on to our next presentation. We have enhanced big data management and analysis through data mining and data fusion using rough fuzzy approach. Dear presenter, could you please proceed with your presentation?
Good afternoon to all of you. This is Aisha Butalia, and I would be presenting on the paper Enhanced Big Data Management and Analysis through Data Mining and Data Fusion using Rough Fuzzy Approach. As we know that there are, the data is day by day increasing, and we have challenges to handle those data, which is now in immense volume and also generated at high velocity from diverse resources and exhibiting various levels of accuracy and reliability. So the traditional relational databases and statistical methods often, ma'am, am I audible?
Yes, ma'am, you're audible.
Okay. Traditional relational databases and statistical methods often struggle to effectively process and analyze such data due to inherent limitations in scalability, then processing speed, and the ability to handle unstructured and semi-structured data formats. So to address these challenges, advanced computational methods have been researched using artificial intelligence, machine learning, and computational intelligence. So one of the promising approach is the integration of rough set theory and fuzzy set theory, which we call as the rough fuzzy approach. So these are the challenges which we discussed, that there is also data security needs to be, it's a matter of concern, privacy, and also a decision-making accuracy where, as said just now, that we are struggling with a reliable data, but from various complex sources in different formats. And apart from the reliability, but there is an uncertainty and also an imprecision in the data. So the approach which we are going to use is the rough fuzzy. So rough set theory is very, very useful in handling uncertainty, whereas fuzzy set is applicable in imprecision type of data sets. So if we combine these two approaches, mathematical approaches, then definitely we would be handling the uncertainty and the imprecision both in the big data analytics. So this is the literature survey done by various researchers, Zhang in 2023, where he developed a rough-based approach for data processing in big data environments. And he used the rough set model for attribute reduction. I myself have a paper in 2008 where I had written a attribute reduction entropy-based algorithm where I had used data mining as a rough framework for rough set theory. And we had used a mushroom plant as a analysis for using the reduct theory so that we can do the feature selection on the same. So in this particular research paper, basically healthcare data, MMICI is used, MIMIC-3, that is Medical Information Mart for Intensive Care database is used, where we have detailed patient records, which include system, test results, diagnosis, and treatment outcomes. So Kumar and Singh sir in 2002, he has used fuzzy set theory along with a preliminary information about the rough set, which can be a future scope. And he had explained much about the integration of the fuzzy memberships. So likewise, after this literature survey, it was very pretty clear that these two mathematical models would definitely give us an insight on the handling the challenges for the big data analytics, and we use the healthcare for the same. So this is what we discussed about the rough set theory, fuzzy set theory, and the combined approach, which would make the system more robust and effectively address the vagueness and uncertainty in the issues. So these are the different techniques related to data set, rough set theory and fuzzy, where we have lower approximation and higher approximation, where, if we say that if the data is confirmedly yes, then that set is approximated to the lower, and the upper approximation has a yes no both type of decision attributes. So when we say that upper approximation minus lower approximation, we get the reduct theory. That's the concept which we use for attribute reduction. So we have also used priori algorithm for the entire data mining process, where we start with the cleaning, the selection, handling the missing values, and trying to extract the unstructured data in a common format, which is very well required when we go ahead with the fusion model. So basically, the profilation of big data in various sectors, including healthcare, which we included in SI's effective management analysis techniques to extract valuable insights for the support decision making. And we propose a novel framework, which we call it as Rough Fuzzy Enhanced Big Data Analysis Frameworks, RFE BDAF, that we have abbreviated, which integrates the data mining and fusion techniques and leveraging the advanced analytical of these combined approaches to enhance data processing, security, privacy, as we mentioned. And we use the MIMMIC 3 model data set for testing. So the detailed, this is how the model works. Okay, so we start with the cleaning, then the rough set theory, where we try to calculate the lower approximation, upper approximation, and then the attribute reduction. And then we go to the fuzzy logic, next module, where we try to associate every attribute to a membership function and try to be more precise on the decision attributes. And then we try to use clustering and classification and regression model integratively to have our decision making in the form of if then else. So the detailed patient records, such as symptoms, test results, diagnosis, and treatment outputs, are analyzed to showcase improved this decision making accuracy and data security. The empirical results indicate a sufficient improvisation after we validate on this data with our RFE BDAF model, which we have designed. We found that it improvised with 8% accuracy as to our previous data sets used, which we have seen from the literature survey papers. And the final accuracy turned out to be 92% rate in the medical diagnosis compared to the traditional system. So this research basically contributes to the development of more reliable and secure big data management systems, ultimately improving the outcome across various sectors. So our one of the objective was to develop a rough set based theory framework as in the model. Second was to improve the classification accuracy in big data, where we use the combined fuzzy set theory and the RST. The third objective, which we accomplished, was to develop a hybrid clustering model algorithm, where we have used the regression and the a priori algorithm for the same, and also the entropy-based reduction technique, and which was applied basically to customer segmentation in marketing in one of the data sets, so that we could analyze whether we could, in different data sets, the abduction reduction technique is being implemented successfully. Next objective was to enhance data fusion techniques on even Internet of Things environment using this approach. And the application which we used was the smart city dataset for traffic management. And the outcome which we achieved was more accurate and reliable data fusion, leading to a better traffic predictions. And this study addresses to the data fusion, focusing on the integrating diverse data sources and ensuring the veracity and the data accuracy of the system. One of the objective was to develop algorithms for the big data analytics using rough fuzzy approach. That was again a challenge, where to handle imprecision and uncertainty, and to develop a decision system. As said, it was a challenge, and we tested it also on the applied to social media data for sentiment analysis. That was actually my model of PhD. So I used that model as well. So, and this also improved the accuracy in the sentiment classification tasks. So we compared, as we said in the literature survey, for the attribute reduction, the classification accuracy, the clustering performance, the data fusion, and the algorithm efficacy. So the application of the workflow, the model, was the data input, then processing. As we said, we use the a priori, then attribute reduction, where we use the entropy based, the fuzzy reference, where we use the fuzzy logic to handle uncertainty in the reduced data set, and the data mining fusion model, where the processed data set undergoes mining and fusion through our rough fuzzy RFB approach. So the experimental setup, where we said earlier that we use the medical information mart for intensive care 3 database. There were around, if I can mention the exact statistics, if you want to know the number of patients and the number of IC units and the symptom records. And then we tested it through the framework implementation, where we used Python with specific libraries such as SCI Skin Learn and TensorFlow for fuzzy logic operations. Hardware and software, we use NVIDIA test GPUs, and Intel Xeon processors were used because we need higher processing for production. The metrics for experimentation we used as accuracy, precision, recall, F-measure, and computational time, which we generally use for our machine learning models. So as we said that using the recall, we achieved the accuracy of 92%, where statistically p less to 0.05 tests were made as compared to the traditional methods. So this is about my presentation. If any questions, I would be happy to answer.
Okay, ma'am. Actually, good presentation, but I have 2 questions. When you are mentioning the 92% accuracy and compare with the existing approaches, so can you tell me how a priori algorithm is suitable to handle the big data? Because normally we are using these techniques for small data sets, and you are mentioning you use the a priori algorithm. So how a priori, is there any challenges? And when you are trying to implement a priori algorithm for the big data, can you mention some challenges?
Sir, actually, we have not used big data for the fusion approach for the decision making. We have used it only for the pre-processing, that is the cleaning of the data, as mentioned in the model. This is the model where I've mentioned we have used only for this pre-processing part, sir. After you find the patterns, then you start your RBF approach for data analytics to have your decision making algorithm.
Okay, and as you said, 92% accuracies. So you compared with which techniques?
Yes, sir. We used the normal fuzzy approach, that is FST model. We used the normal RST approach, rough set model. We used random forest. We used SVM. Okay, so these 4 approaches we compared with respect to time and with respect to memory usage also.
Okay, and what is the new thing? What is your contribution? As you can say, what are the which part you can say this is your contribution or novelty of this model?
Sir, in the literature survey which I said, they introduced in the future scope that fuzzy and rough can be combined, but they have not created the model. They have individually told about rough set theory and the fuzzy set theory individually, which I showed in this literature survey. So I fused this which I have told, they have told it in the future scope. So I implemented that fusion model, sir.
Okay.
And compared with their papers and their data sets for individual, as I rightly said, random forest, RST, FST, and SVM. Of course, SVM is a very complicated model. When I used it in PhD, I find out that SVM and neural networks, they are very easy to tell, but the results are totally vague. And they are called as black box also. So that's why they have called as black box. So, sir, rough set theory was itself my ME and my PhD project. So I know what type of results you get by rough set theory. But adding fuzzy set, it's a complex model where, you know, internally you need to assign membership value to every attribute is a tough task. And then to evaluate on the data set and finding the F score is again a challenge. So I told you 8% accuracy, not a very big amount, but yes, of course, 8% accuracy in terms of if you calculate in time in seconds, it gave you to actually 23% of the time efficiency, sir. The F score I'm telling about the 8%.
Okay. Okay, good, ma'am. Good presentation. Thank you.
Thank you, sir. Thank you.
Thank
This
you,
is
ma'am.
Dr. Aisha Butalia signing off from Pune, India.
Thank you, ma'am. Thank you so much for your presentation. Thank you, sir. Moving on to our next presentation, we have consumer susceptibility, the role of social comparison, reference group, and values. Dear presenter, could you please proceed with your presentation?
Yes, good afternoon. Am I audible to everyone?
Yes, ma'am, you are audible.
Okay, is my screen visible? Because I'm not being able to see it actually.
Yeah, your screen is visible. You may please proceed.
Okay, good afternoon, everyone. So, as the topic says, that it's a study which looked into consumer susceptibility, and we wanted to see the role of social comparison, reference group, and values. So I'll just introduce each of these variables. So in literature, we see that an individual becomes susceptible to any product in the market and goes ahead to buy the product. One maybe to get some reward or to avoid a punishment, apart from just the use of the product itself, also to enhance the self image that I own the particular product. This also makes a consumer susceptible to buy something. So, in previous reports of European Commission, it was seen that a consumer is one who is an outcome or a result of different factors like socio-demographic characteristics, behavioral characteristics, personal situations, and different market environments and trends and practices. These have an impact on someone who is going to buy something. So, in research, also, we see that literature is showing that feelings, motivation, an individual's income, their particular level of lifestyle, opinion, their cultural background they're coming from, their personality, all have an impact on the customer, on the person who is going to buy, and making the person more vulnerable or less vulnerable. Then comes the variable of social comparison. So, in the theory by Festinger, which was a very well known theory, it stated that an individual has the drive to evaluate oneself by comparing with another so that the person gets an accurate self image. And social comparison significantly has an impact on consumer susceptibility, as seen in literature, and it's likely to contribute in making one more susceptible or less susceptible to buy a product. The next variable in our research was reference group. So it's seen that it came up as the concept of reference group came up, and it was defined as a group that is influencing the attitude of an individual, and it makes the individual relate his or her behavior with those whom they use as a reference point to evaluate the situation in which individual is. Let's look at the next variable, which was values. So Rokhish stated that values are very crucial and important in social sciences and in everyday life and living. So according to him, values have an implication in several parts of our life, including how a consumer is also behaving. For instance, in consumer psychology, value as a component help the marketers and researchers to even understand which brand a particular consumer might choose. So we looked into the research gap, and a lot of studies have already been done to understand what consumer susceptibility is. But this particular combination or interplay of these variables in the Indian context, and another special thing we wanted to introduce in our work was to see how it varied during pandemic. So the rationale of our study was we divided the study into two parts. The first part was conducted before the pandemic started, and the pandemic touched every life on the planet, and it was a very challenging time. So we wanted to see how it's affecting consumer susceptibility as well. So just to understand consumer susceptibility a little bit more, it has two sub-factors to elaborate this particular variable, that is informational and normative. The informational factor says that the individual's tendency to accept the information from other people to be something credible about their reality. The individual is taking the information from others to be credible. And the normative is the individual's tendency to comply with the expectations of other people. So, in values, it could be several along several dimensions, including self respect, self fulfillment, excitement, self directed, sense of belonging. These are the ones which are guiding the consumer to whether be vulnerable to a certain product or not. When we looked into reference groups, like the groups which are acting as a reference for the consumers, the informational influence, certain groups are giving information. Information is accepted from others for its content because it is enhancing the knowledge of the individual, be it of the environment. The other is the utilitarian influence, which is based on compliance with other people. And the other is the expressive influence, the individual's desire to appear different in other people's eyes, and hence the individual goes to buy a particular commodity. So we came up with 6 hypotheses dividing it into phase 1 and phase 2. The phase 1, which was the social comparison, will have a positive impact, positive relationship with consumers' susceptibility. The more one is comparing, the more one gets susceptible. The reference groups will have also an impact on consumer susceptibility. Values will have a positive relationship. In phase 2, we wanted to see how consumer susceptibility is during the pandemic, and also we wanted to look into gender difference. So we did the study in India, in Gurgaon. So for phase 1, we had 60 participants, and for phase 2, another 60. They were both male and female, and the age range was between 18 to 35. So the independent variables for our study was social comparison, reference group, values, and gender, and the dependent variable was consumer susceptibility. So we used standardized questionnaires which were reliable and valid. Consumer susceptibility interpersonal influence questionnaire by Bearden and Netmeyer, reference group influence, attention to social comparison, and list of values. So what we found was when we did the correlation between all these variables, we found significant relationships between the variables, independent and dependent variables, but we didn't find significant relation with all of them. But whichever were the significant, we moved on to compute the linear regression. And here we find from what we see in table 2 is that whenever social comparison is increasing, it is also leading to an increase in the informational factor and also the normative factor. Also, we see that every 1 unit increase in the utilitarian influence led to the increase of informational factor as well as normative factor. And also, when every 1 unit increase in value expressive influence was found to increase both of these factors. So next we wanted to see if there is any gender difference in consumer susceptibility. Are males more susceptible or women? So we found that on some of the factors, yes, we did find gender difference, only the normative factor. So we did find a significant gender difference with the mean for male participants to be more in that case. We also looked into the susceptibility before and during pandemic situation, and we found that as the table number 4 is showing that consumers before pandemic had a higher mean for the informational factor. So during pandemic, what we feel the reason for this was pandemic was a time when people just focused on what was absolutely necessary rather than being vulnerable to other products. So coming to the discussion of our work, so the objective was to just investigate the relationship between comparison, reference group values, and a consumer's susceptibility. So the results of the phase 1 indicated a significant relationship between social comparison and reference group with consumer susceptibility. And the results further state that social comparison predicted the normative and informational factors. And we also find similar findings in literature as well. So the first hypothesis was accepted. And the utilitarian influence and value expressive influence was found to be positively related to the informational factor. Similarly, there was a positive relationship between normative factors and value expressive influence. So according to these results, the second hypothesis, that is a reference group, will have a positive relationship was partially accepted. We also found gender difference. So, but only with the males for the normative, so it was partially accepted. And further, the difference was found in the level of susceptibility in consumers purchasing before the pandemic and during, which was observed in the consumers. So the finding indicates that consumers were more susceptible before the onset of pandemic situation. So hypothesis 5 was also partially accepted. So to conclude, in the present work, the relationship between social comparison, reference group values, and consumer susceptibility was studied. In the second phase, we got to have an idea about how pandemic situation had an impact, and we also see gender difference in the consumer's susceptibility. Thank you.
Okay, so as you mentioned, there is very less work on the consumer susceptibility when you compare, when you read some papers. So
Yes.
can you tell me more on your contribution? So it is your contribution. So you have done something on this consumer susceptibility.
Yeah, the main contribution here was what we felt the difference which comes in the pandemic situation. Pandemic, the pandemic COVID affected people across the world, and we just wanted to see how buying was getting affected at that time or how people are getting influenced. So this is it's a work in progress. Right now it's a small work. So we wanted to see, so this came out as the contribution during the pandemic. So
Okay, for that, have you used any data set?
this was raw data collected, yes, from directly from
What about
participants.
the authentication?
Authentication, we used standardized questionnaires, and that was it, sir. Yes.
Okay, thank you.
Thank you. Thank you.
Thank you, ma'am. Thank you so much for your presence. Thank you, sir.
Thank you. Thank you.
Moving on to our next presentation, we have quantum resistant cryptographic algorithms for blockchain integration in financial services. Dear presenter, could you please proceed with your presentation?
Okay, so am I audible?
Hello?
Hello, am I audible?
Yes, you are audible.
Thank you, thank you. So good afternoon, everyone. My name is Jed Joshua Angelo Castillo, and today I will be presenting our paper entitled Quantum Resistant Cryptographic Algorithms for Blockchain Integration in Financial Services. So blockchain technology has significantly transformed the financial services industry. It offers enhanced security, transparency, and efficiency in digital transactions. These features are crucial or important as they help build trust among users and reduce fraud. However, we face a daunting challenge, the rise of quantum computing. This technology poses a serious threat to existing cryptographic standards, raising concerns about the security of digital information, particularly in blockchain systems. Since quantum computers are much more faster than regular computers, they can solve problems that current cryptographic algorithms like RSA and ECC rely on for security. This makes them a threat because they could break these cryptographic methods quickly. To combat this threat, we must develop or integrate quantum-resistant cryptographic algorithms, also known as post-quantum cryptography or PQC. These algorithms are important for safeguarding blockchain systems against potential quantum attacks. Okay, moving on. Here are some of the cryptographic algorithms that are vulnerable to quantum attacks. First is RSA, or Reverse Shamir Andelman, is vulnerable because it relies on the difficulty of integer factorization. The problem here is that Shor's algorithm, a powerful quantum algorithm, can efficiently find the prime factors of large numbers, which compromises RSA's security. Next, we have elliptic curve cryptography, or also known as ECC. ECC's vulnerability stems from its reliance on the discrete logarithmic problem, which is difficult for classical computers to solve. However, Shor's algorithm can also solve this efficiently on a quantum computer, putting ECC at risk as well. Here are some factors in computational efficiency of quantum-resistant algorithms when integrating it into blockchain systems. First is processing time. This refers to the time required to perform cryptographic operations for quantum-resistant algorithms. This can vary greatly depending on the algorithm's complexity and the platform used. Second, we have memory usage. This refers to the resources needed to execute the algorithm. Some quantum-resistant algorithms demand significantly more memory, which can impact the scalability of the system. Finally, system performance. This includes the broader impact on blockchain systems, particularly in terms of transaction speeds and the responsiveness of smart contracts. Quantum-resistant algorithms might introduce delays due to their higher computational demands, which can slow down overall system performance. Now, let's dive into a couple of quantum-resistant algorithms that are being considered for post-quantum cryptography. First, we have lattice-based cryptography. Examples include LWE, or learning with errors, and ring LWE. These algorithms offer low computational overhead, meaning they don't slow down systems much, but they do tend to require more resources such as memory than traditional algorithms. The implementation for these algorithms is generally straightforward, thanks to existing libraries, but working with complex lattice problems can pose significant challenges. Next, we have code-based cryptography, with MacLS being a well-known example. In terms of efficiency, it excels in both encryption and decryption speed. However, it comes with the trade-off of having a large key and cipher text sizes, which can make it less appealing for certain applications. However, the implementation of MacLS is complex as it heavily relies on error correcting codes. For the hash-based cryptography, this approach is highly efficient computationally, meaning it performs well in terms of processing speed. However, the trade-off is that it requires large key sizes and signatures, which can impact overall performance in some systems. The good news is that its implementation is relatively easy as it follows well-established cryptographic practices. Next, we have multivariate polynomial cryptography. It offers substantial speed efficiency, making it appealing for applications where performance is critical. But similar to hash-based cryptography, it has a trade-off of large key sizes, which can limit its practicality in certain scenarios. Its implementation is more complex due to the mathematical operations involved. Now, we'll explore how blockchain is revolutionizing financial services. First, let's talk about enhanced security. Blockchain provides a high level of security for digital transactions. By using cryptographic techniques, which makes it much harder for malicious actors to alter or tamper with transaction data. Second is transparency. Blockchain offers a decentralized ledger that allows for clear and transparent records of all transactions. This transparency fosters trust and accountability in financial operations, which is important. Lastly, efficiency. Blockchain can significantly streamline financial processes, reducing costs and delays typically associated with traditional financial systems. By eliminating intermediaries and automating processes through smart contracts, blockchain enables faster and more efficient operations. Now, let's address the cybersecurity challenges faced in financial services and how blockchain can offer solutions. First, the industry is a prime target for cyber criminals. The high financial stakes in these transactions attract attackers. This is where blockchain can help as a solution. The decentralized nature of blockchain reduces the risk of single point of failure, which is a common issue in centralized systems. With blockchain, security is enhanced as unauthorized access becomes far more difficult due to its inherent design and use of cryptographic mechanisms. Moving on to the challenges of integrating quantum-resistant algorithms into blockchain technology. First, there's the issue of algorithmic compatibility. Quantum-resistant algorithms are not always directly compatible with existing blockchain protocols. This could lead to potential issues with encryption, decryption, and verification processes, which may disrupt the integrity of blockchain itself. Second is key management. Quantum-resistant algorithms typically require large key sizes and more complex key management systems. This means that increased computational overhead and storage requirements could impact the scalability and performance of the blockchain, especially in high-volume networks. We also need to consider consensus mechanisms. Modifications to consensus protocols may be necessary to accommodate quantum-resistant algorithms. This could disrupt how consensus is reached and affect the decentralization that blockchain relies on. Another key challenge is the computational overhead. Quantum-resistant algorithms introduce additional computational requirements, which could significantly impact performance. Finally, we have storage requirements. Storage requirements will increase due to the large key sizes, as I said a while ago, and cryptographic data. This leads to high storage costs and greater challenges in managing blockchain data effectively. Here are the proposed solutions for quantum-resistant blockchain integration. One effective strategy is to employ hybrid approaches that combine post-quantum signatures with the existing elliptic curve digital signature algorithm or ECDSA. By integrating post-quantum signatures with ECDSA, we can ensure a smooth transaction towards quantum resistant while preserving the performance and security characteristics of blockchain systems. This hybrid approach provides a dual-layer defense, maintaining the robustness of current systems while preparing for future quantum threats. Second, we have using quantum-resistant hash functions. By incorporating hash functions that are resistant to quantum attacks, we can bolster the protection of transaction integrity and authenticity. Quantum-resistant hash functions offer an additional layer of security, safeguarding the blockchain against potential quantum-enabled vulnerabilities. Next, we have phase implementation. To minimize disruptions and ensure a seamless transition, we propose a phase implementation of quantum-resistant algorithms. This approach involves gradually integrating these algorithms, starting with the most critical components of the blockchain. By doing so, we can carefully manage the transition, addressing any issues that arise, and ensuring that the system remains secure and functional throughout the process. Next, our lastly, testing and validation. Thorough testing and validation are crucial or important to the successful integration of quantum-resistant algorithms. We must conduct comprehensive testing to ensure that these new algorithms are compatible with existing blockchain protocols. It is important to validate that they maintain the security and performance standards required for blockchain systems. Here are the practical considerations for financial services. First, we have regulatory and compliance issues. When integrating blockchain technology into financial services, regulatory and compliance considerations are important. One critical aspect is GDPR compliance, or the General Data Protection.
Dear presenter, could you please conclude your research?
Okay, let's conclude. Okay, here. As we conclude our discussion on the integration of blockchain technology into financial services, it is important to summarize the key points and outline the strategic considerations for ensuring long-term security and effectiveness. So first, blockchain technology has the potential to transform financial services by enhancing efficiency, security, and transparency. However, quantum computing poses a significant risk to the security of blockchain networks. To address this threat, financial institutions must develop strategies for integrating quantum-resistant cryptography. This involves not only selecting appropriate quantum-resistant algorithms, but also fostering collaboration and standardization within the industry. Several types of quantum-resistant algorithms, including lattice-based, code-based, and multivariate polynomial algorithms, offer strong security measures against quantum attacks. Additionally, hybrid approaches that combine post-quantum signatures with existing cryptographic algorithms, such as ECDSA, can help maintain system performance while ensuring security. When it comes to integrating quantum-resistant cryptography, a gradual migration is important for smooth transition. This process should be supported by thorough testing and validation to ensure compatibility and effectiveness. Considerations include during this transition include addressing regulatory and compliance issues, conducting a cost-benefit analysis, and managing associated risk. In conclusion, ensuring the long-term security and integrity of blockchain technology in financial services requires careful consideration of evolving technology threats. By adopting appropriate quantum-resistant measures and collaborating across the industry, financial institutions can safeguard their operations and continue to benefit from the transformative potential of blockchain technology. So that's all for my presentation.
Okay, so you explain theoretically. So can you give the more focus on your outcome, or we can say that you applied something techniques on some uh, uh, data, or give me the more focus on your contribution. Okay, theoretically you explain, but I need some values.
Sir, here in our paper, we're just recommending this
Okay.
financial services that are integrating integrating blockchain system into their system.
Okay, thank you.
Thank you.
Thank you. Thank you so much for your presentation. Thank you, sir. Moving on to our next presenter. We have trajectory approximation of video based on phase correlation for forwarding facing camera. Dear presenter, could you please proceed with your presentation? I repeat, trajectory approximation of video based on phase correlation for forward facing camera. Okay, moving on to our next presentation. The paper title, Impact of Perceived Risk and Benefits on Intention to Use Mobile Health Applications, Moderating Role of Information Disclosure Intention. Dear presenter, could you please proceed with your presentation?
Yes, I'm starting with, allow me to share the screen.
Yeah, sure. Now, could you please try?
Just 1 minute. Is my screen visible?
Yes, sir, it's visible. You may please proceed with your presentation.
Okay, thank you so much. First of all, many congratulations to the organizers for arranging such a wonderfully planned and executed international conference. I am Dr. Anil from Parul University, Vadodara, along with my partners Neerav Halwadia from Ganpat University and Kedar Bhatt, take this opportunity to present the research works that we have prepared. As you could see, we have worked on the impact of perceived risk and benefits on intention to use mobile health application. So basically our and how the information disclosure intention plays a moderating role to the entire perceived risk and benefit intention. This is what the gist of the paper that we have done. So start with this and go to the next slide. I just want your confirmation that I am audible and clearly.
Yes, sir.
Yeah.
Yes, sir, you're audible.
Yeah, thank you so much. So in India, especially mobile health is a buzzword now. Since post-COVID, a lot of people, youngsters who have got internet access, and they believe that mobile gadgets are not to be used only for connecting, but now they should also use it for their health checkups and to make them fit and ready to fight with any such diseases. Mobile health application downloading and using them frequently has increased. There's a drastic increase in such uses. Along with this, that shows that youngsters and all the mobile smartphone users rather in India are using this technology in their day-to-day life. Also, since the intention to download such applications and use them, there is a special interest of all the stakeholders, the application developers and the startups, that they must understand that why, and in the coming future, why people will go and download such application. Rather, what is the prospect of such industry, whether it will be just as an effect of COVID, whether it will vanish in the coming time, or it will be continue, or whether be a sustainable business or not. So I believe the efforts that we have put in this particular paper would actually contribute a little to take such decisions, especially whether what are the impacts of factors that companies should consider while and accordingly they can design their graphical user friends and other things. So as I was talking about, there are some statistics I would like to share with you. Like mobile subscribers in India is actually 1.2 billions in 2021, and this ratio is increasing every year. And we, according to Deloitte, we can expect more than 1 billion by 2026. We can expect, where in case of adoption of technologies like fintech, e-health, and e-learnings. And along with this, looking at the mobile health market is also growing very frequently, as we could see that it grows significantly, reaches a value of around US dollar 20.6 billion by 2026. Again, this growth is supported by advancement in healthcare technologies, rising chronic disease management, and the busy lifestyle that smartphone users have. Plus, the internet connectivity in India has been increased. I mean, if you go back before a decade, it was not that friendly. People has to pay a huge amount to have good access to the internet. Thanks to the mobile revolution, and now 5G is also introduced in India, so that their user experience and overall experience with smartphone technology has really improved. So we are just this is an effort that we wanted to know that what are the factors that really matters. So we have worked upon the three important parts like perceived risk, perceived benefit, and information disclosure. So with this effort, we wanted to get and connect and try to identify how they are correlated with each other. If I have to talk about perceived risk, is whenever a user often perceive risk associated with mobile health application include like whether the data will be kept very secret, whether it will be data will not be passed on to some unauthorized access. So security vulnerabilities and all this potential misinformation are always in the dilemma of the mobile health application users. So one of the factor, or rather one of the clusters that we have formed, is what the perceived risk that customer might feel. Along with the perceived risk, we have also focused on the perceived benefits that customer might be getting out of having a subscription of e-health applications. For example, health awareness, improved self-management, convenient time to access healthcare services, and accordingly they can manage their diet, time, how many calories they should consume, what are the exercises that are best in case of the chronic diseases, what are the alarming signs, and a lot of other information along with the gadgets they can really make their life easy. Also, information disclosure, the intention is to disclose personal information plays a very crucial role. Like when it comes to disease, okay, if we are talking about diabetes and all this, then it's okay. But when it comes about the diseases which are very much personal, then it becomes very important for the users whether they should be you know are really sharing such information or not, whether the disclosure would be is the right choice or not. That always put them in dilemma. So the users who are more willing to disclose their data are more likely to adopt mobile health applications. So basically, if as a customer, if you are ready to share that information, then you are the right customers or not. So for that, we have done a literature review on the very popular and accepted theories like theory of planned behavior, which talks about the attitude, subjective norms, and perceived behavioral control. Technology TAM model, technology acceptance model, and privacy calculus theory. These are three basic theories that we have used to bring the to get the clusters and questions accordingly. This is our the conceptual model that we have proposed. So basically, we have checked that how personal information disclosure really affects the perceived benefits and perceived risk and intention to use mobile health applications. So talking about the sample size, it was 376 responses were analyzed, representing 39 out of the 39 were female and 61% were male respondents, with the majority age between 16 to 40. As this is, young India, we can call them as a young India or mobile phone frequent users. Also, we have used Likert scale to collect the responses and behavior of the respondents. Clusters we have formed based, as I just discussed, that clusters are formed based on the functionality and security by the researchers themselves. So basically, it's a perceived benefit, perceived risk, and intentions to use. These are some of the hypothesis testing results. We have used smart PLS to test the structure equation modeling, and then these are the results that we could come to know about the hypothesis. Our first hypothesis was how whether this perceived benefits are positively correlated with intention to use health applications, and with the result we could able to support the answer, wherein we have also failed to propose that perceived risk has direct connection with intention of use, which was again into negatively correlated. Moderating effect of personal information disclosures are like perceived benefits directly affecting the intention to use. So the data actually lead us to this conclusions, like there is a negative impact of perceived risk, positive impact of perceived benefits, moderating role of personal information disclosures, because users willing to share personal data are more likely to adopt mobile health applications, especially when they perceive that strong benefits like real-time health monitoring and customized advices. Also, security and communication plays an important role. So there are certain discussions that I would like to continue, like, for example, what are the benefits of using mobile healthcare applications? Like, it's like a 24/7 availability to drive the adoption. It addressing perceiving risk that developer must prioritize security, ensuring technical reliability and regularity, updating the privacy policies so that customer have faith and they should continue and consider that particular app as in one of the trusted applications. Again, that data privacy education is very much important by how the data is protected, that to be informed or make away to the customer. They can further use segmentation, for example, by providing perceived, moderating the relationship between perceived behavior and intention to use. Provider can be tailored strategies to offer privacy safeguards and focus on the trust. Further limitations for the studies are like, this can be generalized to larger population. However, again, cultural factors for information disclosure can be included. So thank you so much for listening. If the presenter has any a panelist, if you can just give your opinion about this. Hello, sir.
Okay. So can you elaborate something about your output finding?
Yeah, output findings are, sir, basically we believe that what are the factors that really matters for the customer. So what I did, I'll just summarize. I already told, but let me just quickly tell it that perceived risk has a positive impact, wherein the associated that disclosure of information is one of the factors that plays a very moderating role. And in case we provide as a company, they can able to ensure the trust, create the trust among the customers. They can expect more mobile health application subscription in the coming time.
Okay, sir. Okay, thank you.
Okay, thank you, sir. Thank you so much for listening. Thank you, the organizers, once again.
Thank you, sir. Thank you so much for your presentation. Thank you, sir, for your valuable questions. That brings us to the end of our presentations. I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on behalf of the whole team, would thank you for all the support during this third version of the conference and previous two versions as well. We would be happy to have you all in the fourth version as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have been forwarded to Springer. The publication would be live within 6 months. So kindly please cooperate with the team of ISBM. So yeah, then I would like to thank our session chair. So thank you so much for your valuable presence.
Yeah, thank
Really-
you, ma'am. Thank you for providing the opportunity as a session chair.
So yes,
Thank you.
we would be happy to have your valuable remarks and feedback to all our participants.
Yeah. Most of the presenters are presenting their work very nicely, and yeah, some of the papers where yeah, we can see that some novelty, their contributions towards the new things is happening in the future. Yeah, definitely some papers was very good.
Thank you, sir. Thank you so much. Just a moment. So, this is a small token of appreciation to our chair for chairing the session. And on behalf of Team ISBM 2024 and Global Knowledge Research Foundation and partners, thank you so much, sir, for your valuable presence. Thank you, sir.
Yeah, thank you, ma'am.
I kindly request all of you to please switch on your camera so that we can have a quick snapshot of this virtual conference. I request everyone to please switch on their camera. Thank you. Stay safe. Bye-bye. Thank you all.